In this session, we're going to be looking at finding horizontal intercepts of quadratic functions by factoring. However, this really just means that you're factoring a bunch of quadratics. If you choose to solve them by factoring, that's a little bit different, but the point is you have to know how to factor them in general. And so for question 1, you need to find two numbers that multiply to 2 and add to 3. So numbers that multiply to 2 would be 2 times 1, or -2 times -1. Those are the only two options there. And we can see that the first pair adds to 3. So we would choose this one because 2 times 1 is 2, 2 plus 1 is 3. And this means that f of x can be written as x plus 2 times x plus 1. And if we set this to 0, so this is just the factoring. This is where factoring ends. But if we want to find the horizontal intercepts, we would set the function to 0. And now either x plus 2 is 0 or x plus 1 is 0, right? Because of the zero product property, one of those has to be true, or both. And so we'll say that then x would equal -2 and x equals -1 would be your horizontal intercepts. Okay. For question 2, same thing. Find two numbers that multiply to -6 and add to -1. So the 2 is coming from, they have to multiply to the c, right, the constant number, and they have to add to b. So here we have -1. That's where that's coming from. And numbers that multiply to be -6, those could be, well, one of them has to be positive, one has to be negative. So it can be 3 times -2, or 2 times -3, or 6 times -1, or -1 times 6. Those are the only 4 pairs of numbers that multiply to -6. And then you can see that if we pick 2 times -3, so 2 and -3, those would add to -1. And so f here would be x plus 2 and x minus 3. And so if we set this to 0, then x is -2 because x plus 2 has to be 0, and that has to be 0. So if we solve them, we have -2 and 3. So those would be your two horizontal intercepts. I now want to do question 8, which is a little bit more complicated. So when we were factoring questions 1 and 2, a was 1, right? For this one and for the other one. But for question 8, a is 2. And so if your lead term is not 1, right, if a is not 1, then you have to do an extra step. So rather than finding two numbers that multiply, here it would be -3, and here it would be -1. What we're actually going to do is find two numbers that multiply to 2 times -3, which is -6. So we're doing, this is called the AC method. So you're multiplying these two numbers and that's what they have to multiply to. So we're just changing the rules slightly of the numbers we have to find. So find two numbers that multiply to -6, and then they have to add to -1, right? They still have to add to this b term. So here that'd be -1. And we can look at the factors of -6 that add to -1. It's actually precisely the ones we were just working with in question 2. And so this is 2 and -3. So what we're going to do now, rather than just jumping into the factoring, is we're going to split the b term into those two numbers. So we'll write 2w squared, that'll stay there. But then this term can be written as, right, so -1 times w. But -1 is 2 minus 3. So this is 2w minus 3w. Hopefully we agree that's the same. So we can write this as 2 plus 2w minus 3w minus 3. So we actually haven't changed anything yet. We just rewrote it in a clever way. And the motivation for doing that is now we can factor out the greatest common factor, which here would be, from the first two would be 2w. So we can rewrite the first two as 2w, 2 times w. What you'd have left is w plus 1. And then we can rewrite this by taking out the greatest common factor, which would be 3, as actually -3. So minus 3 times w plus 1, like this. And now what we have is we can group these terms together, and so we have 2w times 2 times w minus 3 and w plus 1. So you can look at this and you can factor out basically this whole w plus 1 term that would appear in both. And then what you have left is multiples in front. So then the 2w and the minus 3 would go here because you're multiplying that by the whole term of w plus 1. And so this is your factored form, this guy. And if we wanted to find the horizontal intercepts, you would do this the same way. You would say 2w minus 3 is 0. And this would mean that w is 3/2, or 1.5, and w plus 1 is 0, so then w would be -1. So these would be your two horizontal intercepts. These questions are complicated. The factoring can get a bit messy, but this is the procedure that you have to do when a is not 1. The other one that I want to go over is number 6 down at the bottom. So this is there's a trick that you can use here. Of course, you could factor this in the same way that you just did the other ones, remembering that you have to factor out the 64. But what you can recognize is that this is the same as 8t squared minus 6 squared. Right? So that's the same thing. And you can use, once you recognize that that's true, you can use something called difference of squares, which states that a squared minus b squared, so difference of squares, you subtract two square numbers from each other, that is the same as writing a plus b times a minus b. So this is a special case of factoring, and it allows you to do this more quickly, because in this sense, what we're saying is that a is 8t and b is 6. And so what's left the way that you can write this would be a plus b, so 8t plus 6, times a minus b, or 8t minus 6. So this would be your factored form, and then the intercepts you would find by setting each term to 0. And so this means that t is negative 3/4, negative 6/8, and this is positive 3/4. So those would be your two intercepts.